Hey everyone, welcome to the day two of Cloud Digital Leader Certification Bootcamp. Thanks for joining in. Before moving forward, taking you to a quick go-through of what we have covered yesterday. So yesterday we had a session with Neelam Pramar, and she takes us to the whole procedure of how the CDA, how to go through all the CDL processes, how to clear the exams, the most fundamental topics and the important topics of the CDL examination. Today with Aman, we are gonna do the module 1 and module 2 of the session, where we are gonna cover the whole skill boost platform, what has to be done on cloud digital learning platform, introduction to digital transformation, and the innovation with data and Google Cloud. Moving ahead, taking you all to a on a quick note, please to the whole process. So I hope you all must have logged into till now. We are having this cloud digital learning part, which needs to be covered in this whole bootcamp. The first and the second, the introduction to digital transformation with Google Cloud and innovation with data and Google Cloud will be covered today. All the updates regarding the last video, the quiz and everything is on our dashboard. You can check it out. Requesting again, all the updates are on our dashboard. Please make sure you are doing it. Apart from that, we are also running our Twitter challenge on our Twitter. So make sure you are sharing your experiences, tagging Hackerskill, Google developers, Harsh and Arun. We will be also mentioning this on a mail. And yes, that would be great. The lucky winners will be getting amazing swags. All right, then let's start. Let's have Aman on the stage. Aman, over to you.
Thank you so much, Avneet. Hi, good evening, folks. I hope I'm loud and clear to each and every one of you, and I hope everybody is able to hear me properly. So, welcome and I hope that I can see more people joining over here. We get started with the topics, and I'll just explain all the agenda process. And I'll obviously, the first things first, I'll just introduce myself, of course. So just give me a second while I just share my screen. And here we go. All right, I think the screen should be on. Can you see it?
Yes, it's visible.
Yeah, thanks. All right, so we get started. I'll on Puri. I'm a cloud migration consultant for the infrastructure domain at Google Cloud. And basically, I've been in Google for around 8 months now. If you talk about my educational and work background, I have currently about more than 5 years of experience. And my major experience has been working in major of the Google which obviously including. But yes, now that I'm in Google, I have actually got a massive amount of understanding of how Google Cloud Platform provides solutions to the customers, and that's basically what my role is. I basically am a part of the team which helps to drive the delivery solutions to them. So I strategize the right solutions based on the customer requirements, those solutions to the customers, and that's basically what my work is. And I have been providing such solutions in my past companies also as well for these for solutions, and that's I do a lot of that makes mind aging a lot, and I think that keeps your mind keep innovating. And also, I really like to dance, so I generally attend a lot of dance in studios to learn a lot of dance sessions. So apart from that, if you talk I have 3 more professional certifications, which includes the cloud tech, the cloud developer, as well as a cloud DevOps engineer, which really has helped me to upskill and grow my the customers and gain a better understanding. So that's about me, and I hope that you get a good session out of me, and as well as you can take a good fruitfulness of the session, like by asking of questions. So I'm going to keep it a bit engaging. So the agenda of this is about discussing about the first 2 modules. About first of all the fundamentals of cloud. Why do we need cloud? What are the benefits of cloud? And what is the differentiator? Like, why are customers planning to move to cloud from an on-premises infrastructure? What actually differentiates to have an infrastructure on cloud? So that's basically going to be the discussions on first module. The second module would be focusing on the data services, about the data services which are available in Google Cloud. We will obviously talk about infrastructure services in the first modules and the different models which are available. But the second module focuses more on the data, the data services which are available in Google Cloud. Obviously, a overview of those services which you will know what are available in Google Cloud. And to keep it more engaging, I have small quizzes which I want you to see if you can just answer this. It's just going to be like 3-4 questions. It's not a competition. It's just about getting an idea about of how did you grasp from this. That's generally is going to be the part of my engagement. So um, so that's how I will be having this agenda. So with that, I guess if you must have had a session yesterday by Neelam, she must have told you that why it is so important to have certification these days. And yes, it is. Now, what happens generally is, sense of having a path for you to have of certain technologies. Say if I even got a job, I would clear certification on that. What else I used to ask myself to give certificates, and it did got to the notice of the recruiters that yeah, this person has done some certifications, he's really focused on learning, and might have good experience of when you give certificates also that it does help you to have a good across industries that yeah, this person has some certification, he has had some good things. And that's generally something that helps you get the best sort of certificate. It has been great. People, you of it is which basically I will talk about. Second is about what discussing further, which means the cloud versus coal or maybe having both cloud and on premises. We have how does that we understand much further. For those who've done the modules, they might already know what exactly this is, or having a bit of the fundamentals of cloud. We'll talk about the different kinds of cloud options we have when you talk about public, private, hybrid, or multi-cloud, the different characteristics of cloud computing and what do they mean, and how does cloud computing has changed, how it has changed from a more dedicated infrastructure, and it has evolved from dedicated to virtual machines to containerization as a solution, and then to serverless environments functions. Now, when you talk about Google Cloud, Google Cloud's first App Engine was the first Google Cloud service, which was not so earlier compared to 6. Now, what do you mean by cloud hosting? And the first thing what we used to have is, or what we used to have was dedicated servers, like one physical machine which used to run all of our businesses, like web applications, websites, everything. So why that is a problem these days? Because it's very expensive. You have to have a lot of capital expenditure for just procuring a lot of cost for such machines, and it has a lot of high maintenance. Obviously, you cannot maintain such infrastructures. There is a lot of errors or failures which you can have, to be prone to this. These kind of architectures have a lot of high maintenance. Maintenance of that server itself. It's about the maintenance of that environment where it's hosting. When you talk about your organization or wherever, or any data center where you're hosting it, you need to think about your network architecture, everything. And that's something which is a bottleneck in such kind of other, security. So it becomes security solutions in place this solution. Virtual servers where one physical machine was dedicated into a single business, and this physical into some machines. So we used to virtualize all these machines in a single server. And then we have something called where you have one physical machine which is shared by hundreds of business, which relies on tenants, utilizing the resources very cheap and very limited. But this is for that dedicated server itself. But here what happens is your cost becomes cheaper because you share these resources with others into this. Cloud resolve that problem. How cloud resolve that problem? Cloud resolve that problem by allowing you to adapt, not just having one physical servers, but multiple physical machines, which are flexible, which are scalable, which are secure, which are cost effective, and which are highly configurable. So you can have multiple cloud services coming into this case. Now you might be wondering, if one physical dedicated machine, used to have a cost so much, how is cloud benefiting us, especially with the fact that there are dedicated physical machines, having in this case? So that's one thing that is, confuses in our mind. Like, okay, if this is a physical machine here, how cloud is actually having, multiple machines in this case? So it's a matter of capital expenditure and operational expenditure. And cloud works on the operational expenditure. So what is Capex, or capital expenditure in short, right? So it basically means that you're spending some money upfront to buy some physical hardware, right? So in the first previous examples, what you saw was that we, had some dedicated hardware. So obviously when you have to, procure those dedicated hardwares, like your servers, your storage hard drives, your network, your backup costs, your disaster recovery costs, your data centers cost, obviously the physical security, the cooling, the power, electricity, everything, the technical person who's going to manage those things, you will have to pay everything upfront with this, right? What you plan to spend, because you're creating a dedicated infrastructure for you in a capital expenditure. So how do you offload this? You offload this with doing something called as an operational expenditure. So what does operational expenditure means? Operational expenditure means that you will only demand that you require such a hardware, but you're not going to pay for it upfront. You're only going to pay for how much you're going to use for it. Okay. So for example, if you need a machine to run for, let's just say 7 days in a month, you're only going to pay for the cost, the running cost of that machine for 7 days in a month. The other benefit of this is, for such operational expenditure solutions, the management generally in Capex is actually being dependent upon the organization who is procuring these data centers. I'm just sorry, guys. The operational expenditure is actually, the capital expenditure depends, on the organization to procure all the maintenance of these services. But that's not the case with operational expenditures. In operational expenditures, they guarantee the maintenance for you. There's an availability metrics which helps you to maintenance into this. All you need to do is you need to train your employees to learn about these different cloud services. So here the billing is only about the compute and the storage which you use. So here you can try the product as a service without actually doing any or you can say any upfront investments, and you can just try out the service how it is, and you can procure very less cost out of it. So that's basically what operational expenditure means, and that is the reason why cloud benefits here. So you can have multiple servers running, and you're not going to just pay dedicatedly for those servers. You're only going to pay for the time those servers might be running, and that's how you save up on cost by just having that operational expenditure. That's basically one of the benefits of cloud. Next, when you talk about the infrastructures, there are different kinds of infrastructures also when you talk about. So when you talk about your on-premises infrastructures or data centers, which I was talking about, the dedicated infrastructures which requires capital expenditures, that kind of infrastructure is called as private cloud, which is built everything on companies' data centers, which is also called as on-premises. Cloud can be OpenStack, it can be any cloud. There is no dedicated cloud in this scenarios, although Google Cloud and many other clouds also have some private cloud solutions also available with you, like Anchors, which helps you to set up these kind of solutions in this case. But when you talk about private cloud, you basically have a dedicated infrastructure which is already there for your on-premises infrastructure or in your company's data centers. But then you have other solutions which is called as public cloud. So public cloud, basically GCP, right? Google Cloud Platform is basically a very easy example of public cloud. Everything is basically built on the cloud provider, and it's basically called as cloud native architectures or cloud native solutions, what you can have. And sometimes what customers does is, sorry, I'm sorry with my grammar, okay? Sometimes customers want to also utilize both public and private cloud also as well. When you're utilizing both public and private cloud, and you're basically integrating the solutions together, that kind of cloud solution is called as the hybrid cloud solution, where you're using both on-premises and a cloud service provider, and you might be having some kind of a network connection between them by a VPN solution or something like that. There are also other solutions, and these days that's also getting popular, which is also called as multi-cloud solutions. So there are many enterprise customers or many kind of customers who not only depend on just having a single cloud. They also might have another contract with another cloud also, which could be AWS or Azure or Oracle or any other clouds also as well. GCP also provides integration with those clouds also as well. And customers are willingly happy to provide such scenarios also as well, which are called as multi-cloud solutions. Now, why is that a benefit? Is because some customers would like to set up a backup or a disaster recovery infrastructures in other public clouds also as well, or maybe want to run certain percent of services in another cloud also as well, like AWS, Azure, Oracle, or any of these. So that is called as a multi-cloud architecture. So you have many such different architectures available, and you can anytime, depending upon a customer's use case, you can always choose which architecture would the customer would want to go first. Now, what is the main differentiator of Google Cloud, or let's just say even cloud, compared to on-premises environments? Now, already when I discussed about Capex and Opex and about the different types of cloud solutions and why is there a difference in it, I think you already got some of the visibility of why cloud is much better compared to an on-premises environment, or why cloud has a better differentiator in this case. But there are other points also as well. The first point is it's cost effective, of course. As I told you, you can convert your capital expenditure to operational expenditure. Okay, you only pay for your consume, but it doesn't mean that just because you are moving to cloud just for operational expenditure, there is an options where you can also avail upfront cost in Google Cloud also as well, and there are some discounts in such scenarios also as well, which is provided by Google Cloud in these cases. But yes, there is a lot of cost-effective mechanisms when it comes to these scenarios. But is that the only benefit? So no. The second benefit is that it is global. Today, if you want to actually create a virtual machine in any region, you can do that. You can actually choose whatever region you want, although generally the best practice says that your services should be always closest to your region, but that doesn't mean that it restricts you, that you have to only keep it to closest to your region. If today, if I'm sitting here in India and I want to actually deploy a VM in Australia or in United States or in Europe, I can just do it within a few seconds. That's the benefit of what we have in Google Cloud. So I can choose whatever region I want and I can deploy my solutions over there. Second is secure. So the physical security is taken care by cloud providers. So if you would have an on-premises infrastructure, you would have been responsible for even the physical security of the services. This is something which is already taken care by the cloud provider. Like if you see the data centers, they already have a lot of 6 layers of security. There's a very good video about 6 layers of security on Google Cloud. I would recommend everyone to watch that YouTube video. It's called 6 Layers of Security of Google Cloud. And it's a very good video which talks about the whole security of a cloud data center. So you already get a physical security over there. You also have some additional security options where you can secure your solutions by default, or you can add more granular security solutions like firewalls, or any network virtual appliances, etc. The fourth thing is that it's reliable. Reliable as in you can go with some data backup solutions, disaster recovery solutions. Recently, if I don't know, you must be aware that Google Cloud has just introduced their native backup and disaster recovery solutions. And it's not generally available. So you can now natively back up and set up a disaster recovery environment, set up data replication, set up fault tolerance solutions for your Google Cloud platform also as well. And that's generally one of the benefits into this case. Next is, it is scalable. This is a very huge advantage compared to on-premises. If let's just say you have a web application which might be running in 2 cores, 8 GB RAM of a physical machine, and let's just say if it is a web application which is now getting a huge demand of these resources. Now the problem is that because of your constraints of the size of that machine, there's a lot of traffic coming in and it might be causing some downtime to your system because of a heavy traffic load. Now what you want to do is you want to increase the architecture size, or you want to increase the number of machines into this. Now on premises, if you do that, it's a very huge hassle, right? Increasing the RAM itself or the CPU core itself is a huge hassle, or even the storage size is a hassle, or increasing the count of machines itself is a hassle. But when you come to cloud, it's pretty much scalable. You can change the size of the machines on you can say on fly, and you can even increase or decrease resources based on demand or manually depending upon how you want. So that's one very basic, or you can say one of the most important benefit which comes, compared to on-premises. The last thing, which comes into benefit is about elastic. So the scaling, which I was talking about, can be set automatically if there are a lot of spikes, and if you have a lot of drops. Like you can even, if there is a drop in demand or an increase in the load, the scaling can just happen automatically. It can just increase the instances by count. It can decrease the instances by count. So this is something you can automatically configure. And that's generally one of the benefits of, what scalability comes into the picture. Next, let's talk about the cloud models. So there are 3 types of cloud models which are generally preferred in this. These 3 cloud models are as follows. So first of all, we have the on-premises cloud model, and these cloud models basically depend upon some of the resources. That's networking, storage, servers, the virtualization, the operating system, the middleware, like whatever the kernel would be, the runtime. Okay, if you're running an application service or a database, and if you're managing any data applications in this. So in on-premises, you're generally completely responsible about it. Now, this is where shared responsibility model comes into the picture. So shared responsibility model means where once you migrate your applications to cloud, certain of the responsibilities falls upon Google Cloud. partially or completely, and it depends upon three types. First is called as infrastructure as a service. So infrastructure as a service helps to ensure that all the hardware component is basically being managed by Google Cloud, and you're responsible for all the virtualized section of of the services. So if you talk about the operating system, the middleware, applications, and the database and the runtime, that's basically your responsibility. But the hardware responsibility completely falls into Google Cloud, right? So compute engine, VMs, or virtual machine solutions, which is a virtual machine solution in Google Cloud, is one of the examples of infrastructure as a service. Then you got platform as a service, where even the operating system, the runtime, and the middleware is also managed by Google Cloud, and the service is only used as a hosting solution. So services like App Engine, which hosts websites, Cloud Functions, which hosts serverless functions, or Cloud Run, which hosts serverless containers, are such kind of solutions. Desktop as a services, functions as a services, which helps you to only configure your applications and database. You don't need to worry about the internal operating system, the installation of any runtimes like .NET, Java, C#, whatever, any kind of, these runtimes. You don't need to worry about these kind of solutions. So that's where platform as a service comes into the picture. And then you've got something called as software as a service, where even the application and data is managed by the cloud. You only worry about, using, the application itself. So Gmail is one very good example of, software as a service, where you just have to have the content and access, which is everything managed by the Google Cloud Platform, or, any of the cloud platforms. And this is the kind of shared responsibility model, which clouds provides to us. So with these kind of things coming into mind, this is how it comes into this case. So you can see that when you migrate your services into the cloud, some of the things, depending upon which cloud services comes to use, is actually managed by Google, and the other things which becomes a user responsibility. So for example, if I use a virtual machine, like Google Compute Engine, so in that, all the operating system level, everything is my responsibility. But when it comes to platform as a service, like, Cloud SQL or Apps Engine, these services are only responsible for hosting my applications or databases. Rest, everything is basically handled by Google in this case. So this is the shared responsibility model, if you talk about. Giving a more examples about on the infrastructure part of these options, we have if you categorize Google Cloud services in infrastructure as a service, then dedicated servers like bare metal instances and compute engines, or the normal compute engine services, or Google Kubernetes Engine, these come under infrastructure as a service solutions. So here you can see where the responsibility is coming in. So when you talk about the customer's responsibility, the guest OS configurations, the container runtime is basically managed by the customers, but Google generally manages the hypervisor or the physical part of these machines. And when you talk about containers, in containers you have Google Kubernetes Engine, where the configuration of containers is our responsibility, the deployment of containers is our responsibility, the storage of our containers is our responsibility. But the operating system, the hypervisor, the container runtime is Google's responsibility. Similarly, you have App Engine. So App Engine is only responsible for uploading your code, some configuration of your environment, or your deployment strategies of how it is done. But all the hardware, the operating system aspect is being handled by App Engines. Then similarly, you got Word, Google Docs, or any of the the Google Workspace services like Docs, Sheets, Slides, or even Gmail in this case. The content management, everything is done by us, but all the backend service which actually helps us to host these services is all managed by Google. And then you have something called as serverless as a service, you can say, or function as a service. You got Google Cloud Functions, where you just upload your code, and your deployment, your container runtime, everything is generally managed into this. This is actually more of a serverless solution. So what do you mean by serverless means is, it doesn't mean that there's no server behind. There's definitely a server behind, but the server's configuration does not impact the configuration of the functions. That everything, the runtime and the running of these functions is generally managed by Google Cloud. All we need to do is just upload your functions and just set up the execution of how it's going to be executed, and that's how the functions will run. It will not worry you in cases of how these functions might be running, but that's how generally it will work. So when you talk about management versus flexibility of compute, so when you talk about the differences in this, I think you will have a little more clarity on this, since we just talked about the shared responsibility model. It's somewhat similar to that. And here we just see about how the flexibility of compute is. So you can see the whole code level responsibility will be there in all of these services. We talk about from bare metals to functions, you have the full code responsibility. But when you talk about the container responsibility, functions generally offload these responsibilities to Google. In runtime, virtual machines, dedicated host, and bare metal instances are generally responsible from Google's first, are responsible by us. But when you talk about runtimes, that is already being provided by containers and functions, so we don't need to worry on that. And the same cases with OS. And then when you talk about virtualization in bare metal, we need to configure our virtualizations, but everything else has the virtualizations, or the level of control is actually being handled by GCP, and they're responsible into this. And here you can actually now see how the control and the operational costs come in this. Right now, when you talk about compute and Kubernetes services, compute engine and Kubernetes services, it's not that you have less control and you just need to do a hosting solution. It's always a boon. There are sometimes cases where customers may also want the full control in these cases. So that's why they want to go with compute and Kubernetes engine solutions in this case. So in those cases, yes, you may want to actually go with those kind of options, but there is a lot of trade-off of operations, right? There's a lot of committed resources into it, and the pricing will be based on the usage. So more usage comes into more cost, but yeah, that's generally a trade-off which comes into this, but you get more control and you can do more operations in this. When you go to services like Cloud Run, App Engine, and Cloud Functions, the control becomes much lesser. It turns into more of a serverless architecture where you don't need to worry about how the configuration of these servers comes. You need to worry about the number of less operations, and the usage will be just almost the same through around, but it depends upon what your use case is. So if you know that compute engines are generally a virtualization service which hosts virtual machines. You talk about Kubernetes. It was a service which was developed by Google first, and now it's been donated to cloud native computing foundations, and Kubernetes helps you to orchestrate containers. And Cloud Run is also a native solution of GCP, where you can actually host web applications in form of pods or containers. You can actually just deploy scalable containers in this. App Engines is dedicated for hosting more of web applications, and Cloud Functions is for running event-driven serverless functions. So event-driven basically means based on any kind of event, you want to run these kind of functions also as well. So these are some of the services which we were talking about. So I think with this kind of an overview of services, you may have got a gist of how cloud gives a more benefit over on-premises architectures, what are the different types of clouds which are available, and what are generally the shared responsibility model which comes in different clouds, and the different services which categorize the shared responsibility model. So like Compute Engine and Kubernetes Engine is an infrastructure as a service. Cloud Run, App Engine, and Cloud Functions come into platform as a service solutions. And then you have Gmail or any kind of such softwares which comes into software as a service solutions. And Functions is itself a function as a service or platform as a service, whatever you want to call it. But yeah, that's generally how the whole idea is. So with that, I am taking a pause here because I have completed the topics on module 1. I will start with module 2, but before that, I will take a small quiz. But before that quiz, I would like to see if you have a few questions.
Yeah, there are Questions lined up in the chat. Let me just address you for you. Is community cloud and public cloud same? This question is by Ashwarya.
I'm sorry, I kind of lost you there. What cloud is similar? The first.
Is community cloud and public cloud same?
Is community cloud and public cloud same? Okay, so a good question actually. So that's actually somewhat same. If you talk about community cloud as such, it's kind of comes into that similar architecture also as well, because it's something which is coming as in a public cloud as solution. It does have some minor differences compared to a public cloud as a solution. Because when you talk about public cloud basically means which are completely cloud native. Okay. And community cloud also maybe comes into such kind of, a phase also as well, but not exactly, would fall into in the public cloud category, because that's a whole different scenario. But yes, it does come into the same picture if that's the kind of question you are trying to solve.
All right. Second question. Aman, the second question is the difference between multi-cloud and community cloud.
Yeah, thank you. So when you talk about the differences between multi-cloud and community cloud is, multi-cloud, first of all, we need to understand, what multi-cloud is. Okay. So when you talk about multi-cloud is an approach of merging more than one cloud. Okay. So infrastructure, what community cloud means, infrastructure is basically shared between multiple organizations. So it means that it might be using just a single cloud like GCP. Okay. But that doesn't mean that it can use like Azure or AWS. That is multi-cloud. If you're using Azure, AWS, and GCP together, or maybe just using Azure or GCP together, like you're using more than one cloud providers together, that's basically what multi-cloud is. Community cloud basically means that multiple organizations are sharing a similar cloud, architecture, or maybe a similar cloud environment, basically, where the infrastructure is shared between multiple organizations. So in that case, it will be different from multi-cloud, because a community cloud can be one single cloud. It cannot be just having, multiple clouds in this. But yes, I hope that you get the difference between what community and multi-cloud is. I'm muted. Yeah.
Yeah. Then the question is, how Google Cloud better than other cloud platforms as per your experience?
Your voice is getting cut in the middle. So how Google Cloud will I hope that question was how Google Cloud will benefit from other clouds as per my experience. I hope that's a question, right?
Yes.
Okay, thanks.
Yes.
Yeah, your voice is getting cut in the middle, so I was trying to rephrase the question. Okay, so that was a nice question, right? So I'm not going to be biased of being in a cloud, because I have been into experience on multiple clouds also as well. Obviously, Google Cloud is not the first service which actually started as a cloud. There are other clouds also as well which actually started Google Cloud before started cloud before this. When you talk about the first cloud was definitely AWS, and then Azure came up, and then the other clouds came up. Now the question is, how does Google Cloud benefit into these solutions? This depends upon your requirements. Now in Google Cloud, one of the things what I have experienced is that there's a good integration of open sourcing compared to other clouds, right? There's a good focus of the open source technologies here, and Google Cloud is okay if you also want to have integration with other clouds, which I've seen to compare to other clouds. And other clouds, the integration is still there, although I have seen a bit of a resistance in those clouds compared to this. Though they have been, growing, they have obviously been the pioneers into this, but Google Cloud recently has been growing very significantly. In fact, just last quarter, Google Cloud had the highest hike of growth in the quarter itself. obviously it's like, you can say it's growing up, and new services are coming up. And one of the things of cloud is that a service never remains stagnant. There is always something new that comes up for a solution. So cloud is something that requires serious commitment of continuous learning, because even if I just check the portal after 3 months, you'll see, oh, there is something new here and I need to just check over there. So that's one of the things which there. And Google Cloud is definitely in one of those places which is definitely getting a hike over there with a lot of integrations and services. It has a lot of traction on data platforms, especially, into this. And that's generally what helps, with these kind of environments.
Sure, Aman. So a lot of people are asking if we are getting this PPT. So the PPT will be available on H2S dashboard. You can take a look from there. Yesterday's PPT will be also up. So yeah, the next question is, Aman, can you explain Kubernetes clusters and containers as easy as explaining to 6 years old?
Your voice is getting cut again, but I think I got the question. So I think the question here is to have an understanding of what containers and Kubernetes services in a much easier perspective. I hope that was the question. Amni? Okay, so I think I'm going to just take a jibe, and I believe that that's the question. Yeah. So yes, if you talk about containers and how is it different from hosting services in servers or in virtual machines, is when you are creating an application. Let's just say if you're developing a Java application, for example, you need to prepare your environment. You need to actually install the necessary runtimes like the Java and Apache and whatever the runtimes which is required to host these services. So that's generally one of the bottlenecks which comes when you're using virtual machines in this. So what happens is, in such solution is, you have to have your virtual machine will completely be dependent to host that application. So sometimes you want to avoid your virtual machine, and you want to ensure that that isolation is there, that a virtual machine is not completely dependent to host that application. That is where containers come in. So what does containers benefit here is, containers ensure that all of your applications and the runtimes are containerized into an image, and you will use some container runtime solution, let's just say Docker, for example, or in Kubernetes as a solution, which will help you to host these containers, and it will only use the user base of the operating system. So how does it benefit is, you don't need to actually install the runtime, Java runtime or any of the runtimes itself inside the machine. You only need to have the container runtime solution like Docker or something to host these applications. So what happens is, the dependencies, the runtimes, everything is packaged into an image, and all you need to do is just use one runtime to host that application. Kubernetes is not a container service, it's a container orchestrator. So what does a container orchestrator means is, it has a good grasp of management of containers. It does host containers as a solution, but it also has a lot of management capabilities where it helps in some self-healing capabilities of application, which you cannot do with just standalone containers. So if a standalone containers goes down, it may be a little hard to restart those containers. Kubernetes implements those auto scaling and auto healing capabilities, which it has integrated in its Kubernetes solution. So that's basically what containers and Kubernetes is, and it really benefits, and it's become quite a huge traction these days of having containerization as a solution.
All right, Aman. The second question is difference between App Engine and Kubernetes Engine, and for what functions we can use them.
Okay. So App Engines is a platform as a service. Okay. It's only used to deploy a web application Okay, it can be a containerized web application or a stack web application, but these are generally used to host front-end web APIs or front-end web applications generally. That's basically what App Engine is. App Engine helps you to deploy a dedicated web application. Kubernetes Engine is a managed solution of Kubernetes, which consists a set of VMs where the Kubernetes software is installed, which helps in orchestrating containers. These containers not necessarily have to be just web applications. These containers can be any backend services. These containers can be even databases like stateful databases. These containers can even be web applications, of course, but you can host any kind of an applications into this. Now, what difference comes with App Engine and Kubernetes Engine is when you're choosing App Engine, you need to decide on the stack. But in Kubernetes Engine, since those are containers which already have the package stack of an application, you don't need to worry about that it will support only a particular stack. You can choose any runtime stack you want. Your application can be a Python based or .NET based or Java based, and you can run all those multiple containers in the single Kubernetes Engine service, and they can also interact with each other. And it does not host just one or two applications. You can host even multiple services. So generally, Kubernetes Engine is more focused on deploying microservices. So microservices basically means if you have a backend service like a doctor's clinic application, for example, so there are many different modules like user registrations, booking an appointment, or doing a payment, or a doctor just sharing a diagnostics for a patient, right? Now all of these services are basically can be collated as one single service. But what you can do is these days there is also something called as microservices, where in a development lifecycle you divide all of these modules into separate programs. So what you can do in Kubernetes is you can actually containerize those separate programs and make them talk with each other. So that's where Kubernetes Engine gives more benefit. App services generally only dedicated for running some front-end web application or web APIs, basically, or web API backends.
All right, Taman. I guess we can move ahead on the second module and can later take the other left questions. So yeah.
Thanks. Before we start with the second module, I have a few quiz questions, and let me see if you can answer those. We'll take 20 seconds for each question, and let's see what the answer is. So the first question is, a company wants to build an application that stores images in a cloud storage bucket and wants to generate thumbnails as well as resize the image. They want to use managed service, which will help them scale automatically. Okay, from 0 to scale and back to 0. Which GCP services satisfies the requirements?
Guys, you can answer in the chat box. So make sure you are answering in the chat box. We will be surely having some rewards for those who are giving the quiz.
So, okay. So a lot of people are giving, I could see a lot of answers here. Some of them have thought very well and seen what the answer is. So the correct answer to this question is option C. It is Google App Engine. Now, why is that? Compute Engine is a single virtual machine. So you cannot scale it, into multiple machines as such. So we cannot scale into multiple instances in the backend itself. Second option says is Google Kubernetes Engine. Now, there can be actually more debate between the Kubernetes Engine and App Engine, but where you actually, you got the answer is as App Engine is because the question point was saying that it should be a managed service, right? Kubernetes Engine, the problem with Kubernetes Engine is, so someone had also asked a question about, the difference between Kubernetes Engine and App Engine is, you will have to manage the Kubernetes layer or at least have the management of the Kubernetes stack, right? at least do that kind of Kubernetes management. So that still means that there is some self-management involved in Kubernetes solutions. So that will not be the ideal solution in this case. Now, cloud functions generally is a function as a service. This kind of a function is only meant for event-driven processes and not for some kind of an application like a solution. So yes, the correct answer in this case is App Engine, because in App Engine, you can integrate your web application so that you can go into this case also in this case. So when you talk about compute engine scalability, so someone is also saying that why is compute engine not as a solution? Compute engine itself does not give that scalability solution. Compute engine has a different solution called as managed instance groups. So that basically helps with the scalability solutions, right? So the service which helps you to scale our applications is actually called as managed instance groups, which helps to scale this. But compute engine itself is nothing but a single virtual machine. So you will not actually have that much scalability from a single virtual machine. So when you say compute engine is just virtual machine. And if you want to go with a more scalable solution, then it is managed instance groups. Let's go with the second question quick. In the cloud, the recommended practice for security is called a shared responsibility security model. What does this mean? There are two answers here. This one should be easy enough. There are two answers here. Yep, I can see a lot of correct answers here. Yes, I think this was a no-brainer. The answer is D and E. The cloud provider will always be responsible for the physical hardware in the shared responsibility model. That was option D, precisely. And option E says that the business is responsible for the access to data and application. Cloud can be, in certain cases, can be responsible for data and applications, but that would be in cases of software as a service. But in infra and platform as a service, it is the business or the customer who is responsible for access into this case. Obviously, the other three answers are not aligned to that point. So yep, this was a very no-brainer answer to this. I hope this was a good interactive to questions. So are we all ready to proceed with the next module? All right, fantastic, fantastic. Let's go with the second module, and this covers about the data solutions in cloud. Till now, what I talked about was actually about how the shared responsibility model works in Google Cloud, how the data services work, how the infrastructure services are available in Google Cloud, that there are much more services involved in this. But what about the data solutions which is there, and how does Google Cloud innovates, which has different data solutions into this? So in data, there are two categories of data, which is called as structured and unstructured data. Now, what is the difference between structured and unstructured data? As the namesake says, structured data has a structure, unstructured data does not have a structure, right? That's the namesake. But what kind of data is considered as a structured data or an unstructured data? So any of the relational database solutions like MySQL, Microsoft SQL, PostgreSQL SQL, they come under as structured data because there is a structure, they have rows and columns. These kind of data comes under in structured data. And any kind of files, videos, text files, documents, any binary object files come under the unstructured data. So basically they don't have a structure, they are just files. And there is also another category which is called as semi-structured data. So semi-structured data means that there is somewhat a structure, but it is not aligned defined. So some examples of those are NoSQL databases, JSON-based key value pairs. These kind of data generally come under a semi-structured data solution. So when you talk about data or database management portfolios, there's a lot of solutions which are available in these solutions, right? And most of these solutions are categorized in many kind of solutions. There are in-memory databases called memory store. There are non-relation or NoSQL. You can also call it semi-structured data solutions, where we have cloud data store. Now it is called as Cloud Firestore. We also have something called as Cloud Bigtable. In relational databases, we have something called as Cloud SQL, and we have Cloud Spanner. And then we have a data warehousing solution, very popular in Google Cloud called as Bigquery. So these are solutions which are built and managed by Google. But when you talk about building and managing these solutions, you can also, as I told you, that one of the benefits of Google Cloud is open sourcing. So you can also have some open source solutions also, like Redis, MongoDB, Elastic, DataStax, or any kind of different open source solutions which you want to collaborate with Google Cloud and use it in those kind of options also as well. And if you want, you can also deploy solutions on-premises or maybe on compute engines or your Kubernetes engines with database solutions like SAP HANA servers, Microsoft SQL servers, Oracle servers, IBM, even MySQL and PostgreSQL can also be there. Now, what's the difference between using that in a VM and using that in a solution which is managed by Google? As we learned in the first module, the solutions which are built and managed by Google are platform as a service solutions. These are completely managed by Google, and all we need to do is host our databases here. In the right side, which you can see about managing by us or managing by the GC, JKE, these are infrastructure as a service database solutions, where the databases are hosted inside virtual machines, and we are able to host these database solutions in this. Now, apart from these database solutions, now these were all structured and semi-structured solutions, because these were relational databases like Cloud SQL also, or non-relational databases like Firestore or Bigtable, which actually is a structured or a semi-structured solutions. Now we talk about a non-structured or an unstructured solutions where we actually store files. And one of the popular services for storing files is the cloud storage solution. It's a binary large object storage, which is also known as blob storage. You might have heard blob storage somewhere, but that's basically the short form of binary large object, where you can store your files for many reasons. If you want to host it as static files, storing your media, video, images, you want to just store backup, you want to archive that backup, you want to keep the backup in that case. So that's basically what you can do. And if that data is not required by an on-premises capacity, if you feel that there's a lot of data being accumulated of that, you can just dump it into cloud storage as a solution. So and it's a very good solution because you can actually migrate the data in an encrypted manner to this cloud storage. And there are both online and offline transfer options generally available in this. And one of the benefits of cloud storage is that they have something called as classes. Now, what is classes? Classes is generally a classification of data where you actually save your cost of how this data will be used. So how you classify in Google Cloud Storage is as standard, nearline, cold line, and archive. And why is this classification done? It depends upon how much time you want to access this data frequently. So in standard class, you will get a large amount of storage cost in standard class, but it basically helps you to have the most highest performance storage. Like if you want to frequently access the data, or you want to frequently access the data inside that, then that kind of data can be classified in the standard class. Then we also classify the data into nearline class, where the data will be only infrequently accessed. The data is meant to infrequently access, like only once a month. So in that case, what you benefit on is that you get a much lesser storage cost compared to standard. But then if you try to make a more frequent access to this data, you get a more higher cost in this. So that's why the intention of nearline data is to have the access of this data only once a month. Then you have something called as cold line storage, which is intended to have the data accessed only once a quarter. And then you have archive storage, where the data can only be accessed once a year. And from more you go from standard to archive, the more lesser the cost of your storage comes, but at the same time, the more cost of the access to the data becomes. But this is very good considering if you're planning to use a lot of backup solutions and you want to ensure that you're going to keep the data for a long time and you don't want to actually have a year-on cost for that data, so you want to actually classify it into lower classes so that you will be able to save up a lot on the data cost. So that's why this storage classes are concerned in this. Now, a little while back, I talked about that how you can transfer in this. So there are many ways of doing these transfers. So there are many ways of doing these transfers. Either you use the Google Cloud's portal to manually upload the files to transfer it, or you use the CLI tool. So Google Cloud Platform has a specific tool for managing the Google Cloud Storage Service called as GS Util, which helps you to do the transfer, which is a CLI-based tool to copy data into Google Cloud. Apart from that, there is also a cloud-based transfer service called as Storage Transfer Service, where you can actually schedule transfers, and it's a whole managed solution for transferring the data. This also helps you to transfer the data from storage solutions, which are available in different cloud platforms like AWS's S3 or Amazon's or Azure's Blob Storage. So you can actually transfer the data from that also as well by using the Storage Transfer Service. But these are online transfer solutions. If you want to go with a more offline transfer solution, as in you don't want to utilize internet or you don't want to utilize an online transfer options, you want to use some rack-like transfer or use appliances, like basically rack-like transfers, then there's something called as a transfer appliance. This basically gives you an appliance tool which comes to your office location, and you can basically transfer that data, to Google Cloud as such. Right, so that's one ways of transferring the data. There are other storage solutions also apart from this for storing unstructured data. There is also something called as block storage, or also called as persistent disk. These types of disks are actually attached to your Compute Engine VMs. So if you want to use a virtual hard drive which is attached to your virtual machines, you can actually use like block storage solutions like this, in which you have something called as persistent disk, where you can actually attach your disk into this for hosting your servers or operating systems or your applications into it. So you can do that also in this. There's another solution which is also called as network access storage, also called as NAS storage, and Google Cloud has a cloud solution for it called as file store. Now, what is this NAS storage? Is actually, it's like having a common file share between an organization within a network. So in many of the organizations, people use these file shares, like Synology is one of the companies who provides these on-prem file shares. So it's like a common file share stored between the organization, which is being accessed within the network. So there's a cloud solution also to create such kind of a network share, which is called as a file share. And you will use the same SMB protocol, which is the protocol used to access these file shares or file stores, to actually access these file shares. So this can be like a common file share which can be attached to multiple computers or engines or many of the different services, and you can access to all of these services in this case. Apart from the data, these services we talked about, when you use all of these different data solutions, right? We talked about the relational database, all this. Google also has a very smart analytics and AI platform. Okay, so if you talk about Bigquery, also has a solution. They also provide some analytics solutions also as well, where you can analyze the data also as well. And these kind of data can be collected from many of these services. So first you collect from different services, like maybe you're migrating it from some notification services like PubSub, or you're migrating some data, or you're transferring some data through migrations, or you're getting some IoT tools to collect those migrations. Second is, what you do generally is you process the data. So there are many different solutions involved, even in Google, which helps you to process data, like data flow, which is used for streaming. There's a Hadoop or Spark-based architecture called as Dataproc. You have data fusion services, which helps for data integration. And you can also wrangle your data by using the data prep solutions. And then what you can do is you can store these solutions into different solutions. Like you can either use your data analytics, or you can say a data warehousing solution like Bigquery. Then you have your NoSQL, a large NoSQL solution like cloud Bigtable, or you can just transfer the data into an unstructured data solution. If it's just files and videos, then you have cloud storage, or you use databases like Cloud SQL or I'm so sorry, Cloud SQL or Cloud Spanner, right? And what you can do is, by using, processing, and storing these data, you can analyze and activate these data through different services which are available. Like you can analyze with certain solutions like Bigquery. So Bigquery is not only a data warehousing solution, it also helps with a lot of analytical solutions also as well. So it's data warehouse plus analytics solution, or you can even use data prop also as well. And then you can use some AI platforms to use to transform this data. As you get the data which is analyzed and transformed to you, you can actually use the Vertex AI or the Vertex AI service to actually discuss to provide these solutions, and then use other tools like Looker or Sheets or any kind of third-party solutions where you want to actually do some activities out of these data to empower those applications with these transformed data also as well. So that's generally how these things works in this case. So before I come to the ML or AI section of this part, I wanted to just emphasize on the data part. Do you have any questions on this?
Yeah, we have some in chat section, Aman. So yeah, can we get can you explain NES?
Can I explain what? I'm so sorry. NES.
NES.
Yeah, NES basically stands for network attached storage. So someone has already mentioned that in the chat, right? So NAS or network attached storage basically means that a storage solution which is available within a network, okay, which you can attach using a network solution. So for example, let's just say you have an organization, okay, an organization will have their own internal network. So there will be a common file share or common what you can say, a common drive, a file drive which will be available for everyone to attach into their local machines and to access it from their organizational network. So in that there will be like common files which will be accessed by the organizations, and that generally helps with accessing different data also as well. So NAS solutions generally helps to create such common file shares, have it attached with this. So one of the examples what I was talking about was Synology. So Synology is one of the companies who actually creates on-premises file shares like these. And File Store is actually a cloud-based NAS solution or called cloud-based file share solution, which helps us to attach a file share within a network as well.
All right, Aman. I guess the other questions are answered in the chat only by some people. So great work to those who are answering the question. Aman's session was really interactive. Anything else anyone wants to know, please put in the chat box so that we can get you the answers. And all the updates, all the PPT is will be updated on dashboard. The quiz is live, guys. You can take the quiz once you have completed all the 4 modules. Aman, there is a question for you. What is the difference between CDL and A certification?
Yeah, that's a good question. Okay, so CDL, that is the Cloud Digital Leader, focuses on 50% technical and 50% aspects on the fundamentals of Google Cloud. It's like understanding the business requirements. So when I gave the first module, I talked about what is the most of the business requirements which comes, which comes with Google Cloud. Like when I talked about the difference about Capex and Opex, is that a technical need? No, it's a business need, right? So CDL focuses on those business needs also as well as the fundamentals of the technical services which are available in GCP, like the basic services which we have in GCP. ACE, which stands for the Associate Cloud Engineer, is a more technical focused exam where you will actually have to have a little more hands-on knowledge on the services of GCP, right? CDL still only needs the fundamentals, but in ACE, what happens is you need to have a more technical hands-on of different solutions like compute, the network, the storage, the IAM access. How do they actually work, and what is the recommended solution for that? In such cases, you actually you have an ACE. So ACE is a more tech oriented exam, while CDL is 50 tech fundamentally, only on a fundamental basis, and 50% a little business oriented, that why do you need a cloud solution first of all, or what is the business focus of migrating to Google Cloud. Yes. Yeah, Avni, you're muted, I think.
Okay. So yeah, so a lot of people are asking, out of the four modules, which should be studied more, and how much time is required to study for cloud digital leaderboards?
Okay, so out of the four modules, so the focus is quite evenly distributed. So it's just an even thing which comes out of these. So since it's a more of a fundamental course, you're not going to actually worry about that in the CDL session, because in CDL what it is that there's an equal focus of all of the things. As I told, in the previous, when I asked the previous question, that this exam is more technically and business oriented, right? So there's going to be an equal focus on each of the module, because over there, what you need to know is about the core services which are available in GCP, as well as the core requirement of this cloud. So I will not say that there is any, you could say, deep focus on a very particular module for CDL especially, because in CDL it's very evenly distributed, and I can expect it to be evenly distributed as it only covers the more fundamental aspects of GCP in both technical and business formats. And it's more of a foundational experience to understand. This is actually, I would suggest you not to focus on a very particular model, but to focus on all of them evenly, like not too much, but evenly, because this will help you to guide you for the further certifications. Like if you're planning for ACE, or if you're planning for professional cloud architect, this kind of fundamentals will be helpful for you. It gives you a general idea about how cloud works. So I will not say to just focus on particular module. I would say that there should be an even focus in all of these services.
All right. For those who are asking how can they connect to Aman, I will be dropping Aman's LinkedIn profile in chat section. You all can connect with Aman through that. If there is anything more, Aman, we can go ahead. These were the questions people were asking.
Thanks. Yeah, the last part is very quick. Let's see if we can answer a few questions on storage. So let's see if you can get some more answer in this. So global application running on Google Cloud Compute Engine requires access to a file that must be shared between multiple instances, zones, and regions. Which cloud storage option, is best suited for storing the files?
Okay, guys, let's get to the answers. A lot is on A lot of them are saying C. Let's see which is the answer.
Yeah, this answer can be a little tricky between A and C, and I can understand why. Because when you talk about regional persistent disk, you can actually have the disk distributed between the zones. But this regional persistent disk may not help you in providing a multi-regional replication in such cases. So in that case, if you want to have an access to a particular file that must be shared between multiple instances, zones, and regions, you might want to go with a more flexible solution like cloud storage. Now, I know that this is not a straightforward solution in this case, but generally you will go with this. If it would have not been, the option would have not been regional, then I would have definitely, I would have gone with option C, whoever has answered option C here, because that can be shared with multiple disks in this case. But what cloud storage can be done is you can actually make cloud storages multi-regional. So cloud storage has a function of having it in multi-regional or in regional or even having dual regional. There's also something called dual region, like having two regions also in this case. So that generally helps in this. And when you say with instances, it doesn't mean that it has to be directly attached to the instances. They may just want to have the access also in this case. So yeah, cloud storage bucket is more correct to this. And yeah, that's a good job for whoever has answered it. Next question. Your company is looking to utilize the power of GCP cloud. You need to set up a VMs with a stable block storage solution that is fully managed. What is the solution you will look into this? I guess everybody can answer this one. This is something which everybody can answer. What is the solution you need to specify? And it is a stable block storage solution.
So a lot of people is confused between A and B. I can see a lot of B and then I can see a lot of A also.
So as the word says, it is block storage solution. So when you say block storage solution, it has to be persistent disk. So when you say disks, it means block storage, which has to be connected to your compute engine solutions. For those who are saying A is a file share storage solution. Okay, so A is basically a file store, which helps you to basically store as a to store as a file share solution, and B is a cloud storage, which is an object storage solution. So when you say cloud storage is an object storage solution. File store is a file storage solution, but when you say block storage, it is a persistent disk. So this is actually the correct solution. Spanner is actually a scalable relational database solution, which is actually a more scalable solution compared to Cloud SQL, where you can span multiple SQL servers or multiple SQL instances as a platform as a service solutions in multiple solutions. So when you say fully managed, it means it is managed by GCP. You will be only managing the data which you will store in the regional disk, but the disk itself is managed by GCP. So you don't need to worry about how the disk works.
Thanks, you are rocking. You are actually rocking up.
Thanks for that. Yeah. Let's go with the next one. You stream huge amounts of data from devices with sensors. Which storage service should you consider first? Okay, this is a very good one. This I have not discussed a little, so I'm just giving you a little, heads up on this. But I guess for some who have done the fundamentals would get a good idea on this. Okay. So this is a question which is a very favorite question which comes in exams. In most of the exams, even in professional exams, these kind of questions come. This is a question which says that there are data which is coming from devices with sensors. Whenever such kind of data is coming with sensors, never consider using a relational database solution, because relational database will not be able to handle that much huge volume of data. For such kind of solutions, you need to go with a non-relational solution or a semi-structured solution, which actually will help us to go with this. So the answer to this question is option A. It is Bigtable. So kudos for that. Yes, Bigtable is a very large NoSQL based solution, which is actually being utilized for data which will be coming from a lot of streaming devices or IoT devices. So in such solutions, you want to go with Bigtable. And obviously, everybody knows by C, persistent disk is not the answer. So, right, that's definitely the one. And let's go with the last question. So this is something I want you to see if you can answer this. This is something which can, which can come in a twisted way in an exam. A digital media company has recently migrated to Google Cloud Platform. Since they are unfamiliar with GCP products and services, you will be tasked to determine what services are best for their infrastructure. The company requires the ability to ingest streaming data from tens of thousands of IoT devices, right? Process the data through pipelines and store it for analysis. Which service you should utilize for this task? Yeah, here you can have a little bit of difficulty between C and D, but I know that there might be a little debate coming in C and D since there are two confusing words here. One is that you have IoT devices, so you might think that because you have big table, you might want to consider IoT devices. Second is because of BigQuery, right? Because we want to use analysis as a solution. Big table can only store data for IoT devices. However, when you're considering a multi-solutions in Google Cloud, when you're planning to use into this, it's not necessary to just have big table. There are other solutions also provided into it. Now, when you talk about transforming those data, App Engine will not help us to do that. App Engine is basically a web hosting service which helps us to deploy these solutions, right? So the correct answer to this would be option D, because here to actually do the transformation, even if the data is coming from streaming data like IoT devices, you can use data flow to actually do the data transformations. And then you can use BigQuery for doing these analysis. Okay. I think I got a question over here also asking what is the difference between Bigtable and BigQuery, right? So BigQuery is a data warehousing solution and Bigtable is a managed NoSQL based data solution. So BigQuery is actually uses SQL like a relational database, but it's a more of a data warehousing solution, and Bigtable is NoSQL. And another question which they asked that what is the difference between data flow and data prop? Data flows are pipelines. These pipelines actually help you with ETL transformations like extract, transform, load transformations to transform your data. And data prop is a managed Hadoop or Spark architecture based solutions for your data transformations, which uses Hadoop and Spark architecture to that. And Firestore is a, you can say like a more smaller version of a NoSQL data solutions, which are generally used for web applications, for storing user data for web applications. It's like, having user data stored, okay, in a NoSQL solution. That is basically what it, comes in this. Yeah. I'm done with my, any other questions?
So there are few questions on Firestore and Firestores and others. I guess guys, we can put it on the FAQ questions after getting answers from Aman, because we can see Aman is really not well now and needs a big rest. So yeah, let's end the questions. Everyone, you can put the questions in the chat box. I will be taking the answers by tomorrow from Aman and sharing the answers with you.
Yeah, that sounds good. And thank you for being such an engaging audience. I hope like this was a fruitful session for everyone. I hope that you take some good knowledge of this. And all I want you to do is have a good, understanding of cloud. I think you've just started your journey with this because CEL is where you start. So I would just wish all the best to you with your cloud journey learnings. And let's hope that, we see each other whenever we come up with another sessions or something like that. But yeah, I think this was a very good session, and thank you for being such a good engaging audience, and thank you so much everyone.
Thank you so much, Aman, for taking your time. Besides, you were unwell and taking the time, this having this amazing session. So thank you so much to you. I guess like everyone was enjoying and getting the things. Everyone was clearing their doubts. So yes, thank you so much. Guys, this PPT and all the queries will be answered on dashboard. So make sure you are staying updated on dashboard. The quiz is also live on dashboard. So make sure you are attending that. And yes, don't forget to flaunt your badge over Twitter and tagging Hacktheskill and Google developers. It was really nice having you, Aman. Thank you so much. I guess people were loving your session, and we can see a lot of thanks in the chat section also.
Yeah, and I even like the audience myself as well. So thank you so much. This was really engaging for me. And thank you so much of me for this. And yeah, it was definitely a very wonderful session. Yeah.
Thank you so much, everyone. See you all tomorrow with the module 3 and module 4. Yes, Aman, please take care of yourself. You need a rest now. So, yeah, guys, see you tomorrow all. Bye bye.